18 over 35, that is 0.514. Okay, 0.514, so that would be 51.4%. Okay? Is this making sense to you, I hope? Good. So, what about 10? What's it going to be for 10? Anybody? Fill it in. It's 5 more than what we have right now, right? Well, it's 5 more than what we have right now. 23 over 40. So 23 divided by 40, Control Enter. 0.575 exactly. 0.575, so that would be 57.5%. 20, so that's 10 more than we have now. So that would be 33 over 50. 33 divided by 50, Control Enter. That's 0.66. So that would be 66%. 50, 30 more than we're at right now. So that would be 63 over 80. So 63 divided by 80, Control Enter. And that gives us 0.788. 0.788. So that would be 78.8%. And what about 100? That would be 50 more than we have now. So that's 113 over 130. Well, 113 divided by 130. Oops, Control Enter. 0.869. 0.869, which would be 86.9%. Okay? So what about x? What if I just didn't know? Well, what did I start with? I started with 13 over 30, and every single time I just add that to 13. So I have x plus 13 divided by x plus 30. Okay? So after how many consecutive free throws will her percentage reach 80%? Well, if we think about this, if we think about putting this into an equation, y equals x plus 13 over x plus 30, but if we're trying to get to the percent, after we do all that, we have to multiply it by 100, don't we? Okay? So let's go to the calculator for that. Okay, we can just use the sketchpad graph for this. Control divide, remember I showed you that yesterday and maybe the day before? So x plus 13 is in the numerator and x plus 30 is in the denominator. Okay, really hard to see in the window that we have now. Okay, oh, I forgot to do the times 100. Let me go back in there real quick. So tab up here, and I want to say that's times 100. Okay. Now I can't see anything at all right now. I need to see the table, so Control T. So when will it reach 80%? Well, let me do some scrolling here. I'm scrolling on my, looking at my y-axis for that to be to 80%. Right? Almost there. Almost there. Almost. Oh, look at that. So after how many consecutive free throws will it reach 80%? After 55 free throws, or excuse me, not after, so much as at 55 free throws, she reaches 80%. Okay? When will her percent reach 90%? So let's scroll some more. Scrolling, scrolling, scrolling. Boy, this is a pain. You guys think it's a pain too? Yeah, just standing here scrolling. Whoa. Wanted to get it at 90. Oh, not there yet. Sorry. There we go. Oh, look. At 90 free throws. She reaches 90%. So when will it reach 100%? Scrolling, scrolling. Wait, what do you mean it won't reach 100%? I mean, it's still rising. It won't reach 100% because why? Oh, because she already missed some at the beginning. She'd already missed some out of her 30. Okay? So when will it reach 100%? It will never reach 100%. Whoops, 100%. Now, what you need to understand is the calculator will get pretty close. And it may actually round to 100 because it can only hold a certain number of place values. Okay? But you know and I know that since she missed 17 free throws at the beginning, then she'll never get to 100%. Okay? So look at the back for me. Often when using rational functions, when you plug in larger and larger numbers for x, the answers for y keep getting closer and closer to a certain value. This value is called a limit. Okay? It's a value that something gets closer and closer to. So in this problem, what was the limit on her percentage? Well, the limit was 100%. Even though it won't get to 100%, that's where it's going. That's where it's approaching. So graphically, this makes an asymptote. What kind of an asymptote? Well, hopefully by now you figured out that this makes a horizontal asymptote. Okay? Please fill in this page. Answer the question at the bottom. Right? Fill in the page, answer the question at the bottom. What you're looking for in the horizontal asymptote is where is it going to? Is it approaching a certain particular number? It may not be approaching a certain number. And if it's not approaching a certain number, then there's not a horizontal asymptote. And I'll just make it very clear, there is at least one on this paper that is not approaching a certain asymptote. Okay? So just be careful of that. I want to fill in this paper for you really quickly. Okay? This is just going to be a notes page. So when we're finding the asymptotes, first we need to look for the exponents. Okay, first look at the exponents. Find the greatest exponent used in the numerator and find the greatest exponent used in the denominator. We talked about this before, but it's been a while. In each, the greatest exponent is called the degree. Okay? Each one of them is called a degree. So look very quickly at your problem and find out which one of them is greater. Are they the same, or is the denominator greater? Just look. So in this first problem, the degree of the numerator is 2. Since this is the highest exponent, that is the degree of the numerator. Look at the denominator. What's the highest exponent in the denominator? That's also 2. Okay? Compare them. The degree of the numerator is 2. The degree of the denominator is 2. So the degrees are the same. Okay? The degrees are the same. So look back up here at this chart. When the degrees are the same, look at the leading coefficient of the numerator and the leading coefficient of the denominator. Look back over here, the leading coefficients of the numerator and the denominator. So you're going to have a horizontal asymptote of 3/5. Okay? Look at number 2. What's the degree of the numerator? Highest exponent is 2. Look at the degree of the denominator. Highest exponent is 1. So in this case, the degree of the numerator is greater than the degree of the denominator. So if the degree of the numerator is greater, then the function has no limit, so it has no asymptote. Okay? So compare them. Numerator is greater. So we have no horizontal asymptote. Okay? So look at problem number 3. Let's zoom out just a little bit. Degree of the numerator is 1, highest exponent. Degree of the denominator, highest exponent, is 2. Compare them. The degree of the numerator is 1, degree of the denominator is 2. So in this case, the denominator is greater. If the denominator is greater, the function has a limit of 0, and so its horizontal asymptote is at 0. Okay? Last one. Degree of the numerator is 3. Degree of the denominator is 3. It doesn't matter what the numbers are, but when we compare them, we say the degrees are the same. If they're the same, look at the leading coefficients of the numerator and the denominator. In this case, 4 over 2. So we have an asymptote at 4 over 2, but hopefully you know that that's also the same as 2. Okay? Take this paper, get into your notes. You're going to finish this page right here and this question on the bottom for homework. Right? Any questions? I mean, not that I can answer them because I'm not here, but just polite to ask. I don't know. All right. Have a great day, and I'll see you later.